For this, I wanted to finish the handout that we were doing for transformations on trig graphs. We did example number 1. Let's try example number 2. We'll put example number 2 here that says f of x is equal to 2 cosecant of x minus 1. Remember what I said? I like to write it as y is equal to a negative 1 plus 2 cosecant of x. We need to remember that cosecant is just 1 over sine, so we're going to graph this as if it was sine of x. We would still find that the amplitude is equal to 2. That's this number right here. We also know that our trig axis is going to be y is equal to negative 1. That's this first guy right here. So from my graph, I do know, if I come over here, that I'm going to go to y is equal to negative 1. That's this guy right here. This is my new trig horizontal axis. And I also know that I'm going to go up to from here, 1, 2, so the most it will be is here for my sine wave, and I go down 2 from here. That's the bottom of my sine wave. So I know it needs to fit in between those two. From here, we're going to find that omega is equal to 1 because there's nothing in front of our x. We know there's a 1 there. That means our period is equal to 2 pi over 1, or 2 pi. So it's going to look like our normal sine graph going from 0 to 2 pi to make a wavelength. And we do not have a phi, or a phase displacement over omega that's equal to 0. So we're going to start right here. So our new axis, my y-axis is still my y-axis. So our graph starts here, and after 2 pi it will finish here. So remember, 2 pi is over here. 1, 2, 3, 4. This should be pi. 1, 2 is at the highest peak. In between these two, it is at its lowest peak. So here's our sine wave. Notice I'm putting it nice and light because we really don't want the sine, we want the cosecant. So we're going to make sure we do that. I'm going to come over here, go down to its lowest point, to its axes, and then to its highest point, and then back down to its axes. So we can see our cosine like this. I'm going to get a color marker to denote that we have asymptotes when it crosses our horizontal trig axes. So when it crosses my dashed horizontal line, that's where I'm going to put my asymptotes. From here, I'm going to finish my graph by going to the top peak and making U's for my graph. And that's our graph. For example number 3, let's try graphing y is equal to 1 plus 3 tangent of 2x. And I'm choosing these on purpose because I know you probably are very familiar with sine and cosine, but maybe not so much with tangent and cosecant. Again, we would find that our amplitude is equal to 3. We find that our axis is y is equal to 1. We find that omega is equal to 2. That's this guy right here. That's omega, our frequency. We can find our period by doing pi over omega, or pi over 2. Remember that we don't use 2 pi if it's tangent or cotangent. We use pi. So we know that it takes pi over 2 in order for it to start repeating itself. So let's see some points, see if we can kind of get some idea. We don't have a shift left and right, so it's going to start as if it was a regular tan graph. We're going to do tan of 2x. So if we put in 0, tan of 2 times 0 is still tan of 0, which is 0. So we're going to start here. And then I'm going to do pi over 4. If I do pi over 4 and I multiply it times 2, I get pi over 2, and the tangent of pi over 2 is undefined. So we know that at pi over 4, and I'm just going to label this one pi over 4, it's undefined. So I have a vertical asymptote at pi over 4. From here, I know that if I add pi over 2 to that, so pi over 4 plus pi over 2, That's the same thing as 3 pi over 4. So if I come over here in my graph, that's 1 pi, 2 pi, 3 pi over 4. I'm going to have another vertical line there. And I'm just going to keep that same pattern. So I do the same thing over here. It's going to be at negative pi over 4. And then pi over 2 away, pi over 2 away, pi over 2 away. In between, we're going to end up at the 0, so we're going to make sure we keep those zeros there. Oh, I lied. We actually need to go up to y is equal to 1, so that's going to be up here. That's where my zeros are going to be. So I apologize. I forgot to graph this guy. So I'm going to put my zeros up there. So it's going to be here. It's going to be here. And then we're going to make our little tangent going from negative through here, make it look like a Gumby kind of thing. And that 3, amplitude of 3, just means that normally we would have gone over a quarter and then up 1, but it says 3, so 1, 2, 3, so it gets up steeper than normal. Remember what I said, you don't have to be perfect with these, but we do need to know the general shape of them. You don't have to do as many as I'm doing, but at least 2 cycles. So only because I created this mini, I'm going ahead and finish this mini. And there's our guy